Welcome everyone. In this video, I want to go over problem number 3, section 2.5. So, which we're using the minimizing theorem. So let's see how that works. So let's read the problem first. In the final example, so we have the example here of this section. We ask if certain subsets of S which contains those vectors W1 through W5 were also a basis for the three-dimensional subspace W, which is the span of S. Decides whether or not the following subsets also form a basis for W. Now, in the example, please go over the example yourself. So here to see if any of those can form a basis, what you need to do is write these vectors as columns of a matrix. And here, for the first problem, these are the rows, but then here we have it. So they called it in the example. Please go over the example. The A, which is the transpose of B, and these are our vectors. So you write them as columns of this matrix. Then you can find the RREF of that matrix. And when you find that, you're going to get 3 pivot columns. So 1, 2, and 3. So C1, C2, and C4. We know for sure these are linearly independent because they are pivots, so they can form a basis. But is that the only basis? Let's double check. Now, A is asking for W1, W3, and W4. So W1, W3, and W4. And it's pretty simple to see when you look at the RREF. We want to know if C1, C3, and C4 are linearly independent. And if you kind of check those, so there's no way you can write C4 as a linear combination of C1 or C3, or you can't write C1 as a linear combination of C3 and C4. So these are linearly independent. Although this is not a pivot, but you just check, and it's very easy to check in the RREF. You can write that as a linear one as a linear combination of the other two. Since it's not, that means they're linearly independent. If they are linearly independent, then they can form a basis. So the answer is yes for A. For B, so we want W1, W4, and W5. W1, W4, and W5. Let's check the RREF. So C1, C4, and C5. Can we write C5 as a linear combination of C1 and C4? No, it won't happen. So because we have zeros here and then a 0 here, there's no way you can multiply C1 and C4 by a couple of numbers and get C5. So these are linearly independent. So therefore they can form a basis. C, W1, W2, and W5, W1, W2, and W5. Let's check. Can we write W5 or C5 as a linear combination of C1 and C2? Yes, 4 times C1. If you multiply 4 that by this vector and minus 7 times this vector, then you are going to get that vector. So they are not independent. If they're not independent, then they cannot form a basis. So the answer is no. And here I wrote 4C1 minus 7C2 is going to give you C5. Therefore, the same thing will work with this original matrix. 4W1 minus 7W2 will give you W5. Please try that yourself, and that way you won't forget how it works. Next one, W2, W4, and W5. W plus W1, W2, W4, and W5. Let's check. So C2, C4, and C5, and we see clearly that you cannot write C5 as a linear combination of C2 and C4. So that's not going to work. And or any of the other two. So these are independent vectors. If C2, C4, and C5 are independent, then automatically W2, W4, and W5 will be independent, so they can form a basis. E, W1, W3, and W5. So let's check C1, C3, and C5. I already see we have numbers here and a number there, and we have a number here. So a number here and here. So I can kind of tell that C5 can be written as a linear combination of C1 and C3. So let's see how we can find those numbers. Here you can say, for C1, you can say X plus 3 times Y equals to 4, and negative 2Y equals to negative 7, and just solve for X and Y. And if you do that, you're going to get X is negative 13 over 2 and Y is 7 over 2. So I can say that negative 13 over 2 times C1 plus 7 over 2 times C3 is going to give me C5. So, and you can try that, it will work. So therefore, we can say negative 13. Now, well, here I wrote it, negative 13 over 2 C1 plus 7 over 2 C3 equals to C5. Therefore, we can write negative 13 over 2 W1 plus 7 over 2 times W2 is going to give you W5. These vectors are not independent, therefore they cannot form a basis. Finally, F is, it works the same way, W2, W3, and W5. Look at C2, C3, and C5, and yes, you can write this as a linear combination of these two because we have numbers here. So if we match them, so, and I didn't do that, but I let you do it yourself. It's, you can write just a simple system like that and find that, but then just by inspection, we can tell C5 can be written as a linear combination of C2 and C3. Therefore, W5 can be written as a linear combination of W2 and W3. So that cannot form a basis because these three vectors are dependent. I hope this helps, and I'll see you in my next video. Have a good one, everyone.